So you won't always have a SIM solution at your fingertips. Or maybe you need to investigate an endpoint or a piece of infrastructure that doesn't have a SIM agent installed, or the forwarding wasn't set up, and so we have to rely on local log files. Or what's also common is maybe you were just handed a log file during an incident to analyze. And while it's possible to manually extract out these logs and then manually upload them into a SIM, it's again not always an option for us. And like the methodology that I've been pushing all throughout this course, it's important for us to know how to do things at a low level before we start relying on tools that can take a lot of the work and effort away from us. And tools are great, right? Don't get me wrong, I love tools, I love automation, and I love SIM solutions. But we need to know how to manipulate logs and filter out fields, or look at statistics, and work with them manually to extract what we need in a pinch. And so this brings us to the command line log analysis lesson. And there are many built-in Linux commands that we can use on their own, or more powerfully combine and chain together, which allow us to parse and filter out relevant information quickly, and even look at high-level statistics about our log file. And so let's hop over to our Ubuntu lab machine that you can see here, and head over to the SIM directory. And then over to the log analysis folder. And from here, well, you can see first off, we have an access.log file. And this is a log file extracted from an Apache web server. And with Apache, well, its logging system is going to record a number of different events that occur on the web server within various files. And so we'll get details about the client's request and server responses, or any errors within the error.log file as well. And specifically, the access.log files will typically give us detailed information about each request made on the web server. So things like the IP address of the client, the timestamp of the request, or the requested URL, or the HTTP method and the status code, and even the user agent strings. And we actually looked at a couple of examples in the previous lessons. And so when investigating an incident that involves a web server or web traffic, well, these types of logs are very useful to have in our arsenal. And so we're going to start out by working with some web server log files first, but the methodologies we cover here are going to apply to pretty much any semi or unstructured log format that you come across. And so if we've just been handed this log file to analyze or look through in a ticket, or manually hopped on the endpoint to extract it, well, there are a couple of different things that we might want to look at first to get our bearings and understand the scope of what we're going to be looking at. And so first, let's start off with the file command. And we've used this before, but the file command helps us determine the type of file that we're dealing with. And so we can quickly use it to identify the format of the log file and ensure it's what we expect. And so I'll just provide the name of access.log, and in the output we can see ASCII text. And so this means that the file contains plain text, written in the standard ASCII character encoding, which is just another way of saying it's a readable text file without any fancy formatting. Which is good because it means we can work with it and manipulate it to analyze and get what we need. And so next, we want to understand the scope of the file, right? How big is it and how many lines? And similar to looking at things like the packet count in Wireshark, well, it helps us determine, again, the scope of our investigation and the amount of data or events that we have access to. And there are a couple different ways to do this. And my favorite way is just to run ls with the LH parameters. And so L here is going to list out the files and directories in a long listing format. And so we're going to get more detailed information. And the H here makes the file sizes that appear more human readable. And so we're going to get sizes in things like kilobytes or megabytes. And so I'm just going to append the name access.log here. And you can see, based on the file size that's returned, well, we have 343 kilobytes. And so this is useful from a file size perspective, but what about the individual entries or logs? Well, for this, because each log or event is on its own separate line within the common or combined log format, or CLF, well, we can use the word count or the WC command. And this is just used to count things like the new lines, or the words, or the actual bytes or characters within the file. And so if I just provide the name of access.log, well, you can see we get 3 different numbers here, each representing different counts. And so 3086 here represents the lines in the access.log file. And so technically we have 3086 events to go through. 41,767 here represents the number of words in the file. And lastly, 35810 here represents the number of bytes or characters. And so realistically, we're only really interested in the number of lines because, again, we can equate those to the number of individual events. And so we can run word count with the TAC L option here to only count the number of lines. Or with tag W here, we can count the number of words. And lastly, with tag C there, well, we can just count the number of bytes or characters. And so it looks like we have around 3,000 entries, which honestly isn't too bad. Depending on the server and the time frame you're investigating, well, you might be handed a log file with tens or hundreds of thousands of events. And so, speaking of timelines or time frames, knowing the actual range of time that we have access to in the log file is extremely useful for us. If you remember back to the packet analysis section, well, it's often important for us to confirm the time range in the logs or in the capture to make sure what we're about to spend time investigating is actually relevant or actually fits the timeline of the incident or whatever we're looking for. And there are some clever one-liners or utilities that we can use to extract out the timestamps from the first and last event. However, we can just stick to using good old head and tail to only output the first and last lines of a file respectively. And so I can just run head against access.log. And by default, the head command is going to pull back the first 10 lines of the file. However, we can also append the n option here and specify the exact number of lines that we want to pull back. In this case, I'll enter the number 1 to only pull back the first line in the file. And you can see here, well, we get the first event in the file. And we can see based on the timestamp in the log entry, we have July 17th at 18:47:37. And typically you'll want to convert these timestamps into a common zone like UTC, but we don't need to worry about that for now. Similarly, we can run the tail command against the same file, and once again provide that tag n option with the number 1 to only pull back the single last line in the file. And in doing that, we can get the final timestamp of the last event in the file. And so in this case, we have 18:50:13 on the same day. And so we have about 3,000 log events within that 3-minute period to dig into. And so notice we haven't even read out the file yet, which we could do if we just run something like cat. However, look at all the information we're getting here, and this is just not really usable to us, right? Especially with over 3,000 lines. We can't just be scrolling through this and hoping we find something interesting. We could paginate the output to make it a bit easier to scroll through the lines, and we can do that either by using the more command. And the more command is a very basic pager that allows us to display the contents of the file one screen at a time. And it stops, you can see, after each screen, and waits for us to press the spacebar to display the next page or text. And so we can just press Q to quit that. Or alternatively, we can use the less command. And this is an improved version of more, which allows us to actually scroll backward and forward, or use the arrow keys up and down to go back and forth through the text. And again, I'm just going to press Q to quit there. Because we're not actually overcoming the issue that this is just way too much information and events for us to go through, right? And so let's go back to our methodology that we've been developing, and let's zoom out, so we can start gathering some statistics before we start diving into any interesting IOCs or events. And some of this is going to be familiar to you from the network analysis section, because we actually use some of these utilities and chain them together when we were working with TCP dumps output. And so the first utility that we want to look at here is the cut command. And the cut command in Linux is used to extract sections from each line of input and manipulate the text files by selecting specific columns or fields based on a delimiter. And so let's take a look at how these events or these single log entries are made up. And so I'm just going to go back to my head command here to pull back the first line, and we can see an example of one of these log entries. And so while this log is semi-unstructured, we don't really have any set delimiters other than the space character that you can see in between some of these columns. However, you can see the first column here in the file, well, represents the IP address used in the web service connection. And then we have a space and then a blank column here, another blank column, and then after this space, well, we have the timestamp. And then we have this long string containing the GET request itself. And then we have the HTTP status code, in this case 200. And then the response size. And confusingly, this is also 200. We have another blank column here. And then lastly, we have this long string of the user agent. And so this is what we have to work with. And so first, I think the IP addresses would be great to aggregate and count up to see if we can quickly identify any patterns or figure out at a high level who was accessing the website. And so to do that, I'm going to run the cut command against the file. And with the D option here, if you remember, we're going to specify the delimiter that we want to use. And so in this case, we mentioned that some of the delimiters here are using the space character. So for example, we have a column here, and then we have a space. with another column, a space, another column, a space, and another column. And so what we can do is set the delimiter within quotes here, and I'm just going to press the space key to insert a blank space as our delimiter. And next, we have to provide the F option to specify the field that we want to extract. And we do that with a number. And so, for example, if we were using the space as our delimiter, well, anything to the left of our first delimiter is going to be the number 1, because this is the first column. And the column directly to the right of this first delimiter is going to be 2, and then 3, and 4, and so on. And so what I'm going to do here is just enter the number 1. And so now with this, we're still outputting every log in the file, but this time we're only extracting the IP addresses. Expanding on this, we can change the field that we're extracting here to the number 7. And this is going to extract any specific URLs in the GET request. Or we can change this to 9 and extract any of the HTTP status or response codes. But let's just stick with IPs for now. And so once we've extracted the IP addresses, we can sort them to identify patterns or count up unique addresses. And well, to sort, we can use the sort command. And so what we'll do is pipe the output of this previous command into the input of the sort command to sort all of the IP addresses alphabetically. And now that we've done that, we can now use the unique command to filter out any duplicate lines or lines that, when sorted alphabetically, are right next to each other. And this should cut down the results quite significantly. However, we still have a lot of listings, right? Let's see how many in particular by appending the C option to unique to count up the list of aggregated entries or their individual occurrences. Okay, so I'm already starting to see an interesting pattern here, where we have a specific IP address with a large number of connections. You can see for the most case, a lot of these IPs just have one or a single connection here. And so this entry sticks out. But to look at this properly, let's sort out our output once more. Specifically, let's sort it based on the numerical values of the counts that we're pulling back. And so to do that, we can run sort with the -nr command. All right, good. And so now we should have the IP addresses with the most occurrences up at the top. And we do. All right, so now what I want to do is throw in a grep statement in between here to filter out any of the IP addresses with a count of 1. And so to do that, I'm going to use the same command here. But after our unique statement, I'm going to append another command in between here. And so what I'm going to do is just run grep -v to exclude, and then in quotes here, I'm going to exclude anything with a space with the number 1 and then another space. And in doing that, you can see we've successfully extracted any of the counts that just have a single entry. And it looks like we have 2 interesting results. Okay, awesome. And so it looks like we have some specific logs that we might want to dig into. We can see that this first IP address here is making a heck of a lot of connections, over 90% of them in the file. And so that's something we want to look into. We might want to see where that IP address is coming from, or what its reputation is, right? And so all of our investigation steps still apply here whenever we find an IOC like an IP address. And so I can copy this IP, and perform a lookup on it. And you can see it's based in Ukraine. I can also use Cisco Talos Intelligence. And so I'll just paste in the same IP here. And we can see it has a poor reputation. As we scroll down, well, we can see under email reputation, well, this IP address has a number of poor results. And so that's not super telling on its own, but let's keep these IP addresses handy. And so now what I want to do is look at the user agents across the file as well. And to figure out how to do that, well, let's look at another sample log again. And so it looks like the user agent is wrapped in these double quotes. And so we can use the cut command once again and specify the quotation mark as the delimiter. Well, you can see we're already using these double quotations to enclose our delimiter itself. And so if we just have a third quotation mark here, well, that's going to error out. And so what we need to do is escape our quotation mark by putting a backslash in front of it. And this will check out just fine now. And for the field, well, sometimes this might require a bit of playing around with the values if you're not counting manually, right? But this is just the process of extracting out fields within logs of this structure. And so in this case, let's input the number 6, which is going to map to the user agent. And then just provide the name of the file. Okay, great. And so now we're just pulling back the user agent strings for each line in the file. And so now let's do the same cut and sort and unique tricks to filter out and extract the unique values. And so I'll run the same command again and pipe the output over to sort, and then pipe that over to unique and count up the occurrences with the C option. And then lastly, pipe this to one more sort command to sort based on the numerical values. Interesting. So it looks like we have a number of benign looking user agents, right? We can see Windows here. We can see it's running on Chrome. In this case, it's running on Firefox. However, two specific user agents really stick out to me here. And can you identify them? Well, first, we can just take a look at the count of results. And in this case, we have almost 3,000 entries with this specific user agent here. And if we have no idea what this is referring to, well, why don't we just copy the name of the user agent, and we can simply Google it to see what comes back. And so within quotes here, I'm just going to paste in that user agent. And in doing that, well, we're seeing a lot of results here referencing the Hydra tool, or references to brute forcing web forms. And if we just look up the Hydra tool, well, we can find this Kali Linux repository. And so this appears to be some sort of password brute forcing tool. Back to our results here. Well, the second interesting user agent is more verbose. And so in this case, we can read out Nmap scripting engine. We even get a URL to look at as well. And similarly, if you weren't familiar, well, we can just Google this as well. Where we'll come to find that Nmap is a network scanner that's used to discover hosts and services running on an endpoint. And so based on these events, it's clear that someone was trying to scan and brute force the website. And so let's use some of what we've identified to pivot around in this file and try to find these interesting entries. And so first off, I want to see where these scans were coming from. And so what I'll do is run the grep command to do a search within our file. And the string that I'm going to search for, well, is nmap scripting engine, because this is the string we found within the user agent. And then I'll just provide the name of our access.log file. Okay, excellent. And this is a bit zoomed in here, so I'm going to zoom out a bit. And so we're seeing a lot of entries from this 62.122.201.246 IP address. And this is the same one that we identified earlier as having the most connections. And so it looks like this IP address performed an Nmap scan against the website. And we can see based on the request strings here, well, it was looking to enumerate specific information about the web server and its configuration using methods like option and post, and trying to pull back pages like robots.txt or .git. And so now let's do the same for the Hydra user agent. And so to do that, I'm going to run the same command, but in this case, I'm just going to paste in that Hydra user agent that we identified. And that's going to be Mozilla /5.0, and then in brackets here, the word Hydra. And so if we run this, well, we get a lot of output. But all I'm really checking here is what IP address made the connections, and what specific page on the website were they trying to brute force. And we can see we have the same IP address here. And it looks like it was running a brute force attack against the /login.php page. And so to double check there were no other IP addresses or different pages listed here, well, we can use the same cut and sort combo that we've been using, but I also want to show you the awk command. And awk is very powerful. It's basically its own utility in scripting language that we can use to pattern scan and process our files. And the most basic way to use it though, and the best way for our use case, is to use it to conditionally filter out certain entries. And so what I'll do here is run the same grep command, looking for this Hydra user agent. And then I'm going to pipe the output here into awk. And then within single quotes and curly braces, I'm going to type print with the $1. And this refers to the first field. So this is kind of like a variable, pretty similar to what we were doing with cut. And if I run this, well, you can see, again, we're just pulling out or extracting that first column. And what I can do now is just pipe it over to sort, and then lastly to unique. And to confirm, we are just getting one IP address back. In this case, about 3,000 entries. Okay, awesome. Now, when investigating a password brute force attack on a web page, typically as an analyst, we're looking for 3 different things to verify if an attacker was able to gain access. First, we want to see if the URL or the path on the website changes at all in the logs, indicating that an attacker was successfully logged in and was maybe redirected to a different page. Second, sometimes more importantly, we want to look at the HTTP response code, as that can be another tell for us. For example, historically, a standard invalid credentials response code would be 401, or the unauthorized response code. However, that was more relevant back when websites were a bit simpler, and we don't have things like single-page applications, or websites that use more sophisticated JavaScript frameworks. And so typically nowadays, we'll still see a 200 or a normal OK response, even if credentials were entered incorrectly. But what we can look for is any other changes that might indicate a successful login, like the HTTP response code of 302 or 301, indicating a redirection. The third thing we might want to look for is any change in the response size. For example, if credentials were entered incorrectly in a brute force attack, well, the attacker might get a 200 OK response. But they might get a smaller response size that just renders something like incorrect username or password. However, if a brute force is successful, well, the attacker might be presented with a user dashboard or an admin panel, which would typically consist of a much larger markup and would have much longer response sizes in bytes. And so it's just another deviation or anomaly that we can look for. And so just to demonstrate the power of awk, well, let's pull back the 9th field this time. And so what I'll do is just run our same command again and back this out. And instead of the first field here, I'm going to change this to the number 9. And as we run this, well, you can see we're getting a lot of 200 responses. However, let's filter this to look for any response code over the number 200. And this is so we can see any anomalies. And so to do that, well, we can just change our awk command here to do some comparisons. And so again, in single quotes here, what I'm going to do is present the 9th field, and then with a comparative operator, I'm going to make sure that it's greater than 200. And if we run this, well, there we go. We're getting a single entry returned. And why is that? Well, it looks like the attacker got a 302 redirection response. And so it looks like potentially the attacker was able to brute force a successful username and password combination and was redirected to a different page. And so let's take a look at this timestamp in more detail. And so I'm just going to copy it to my clipboard. And let's try to pull back any related logs around this time frame in the file. And so first off, what I'll do is run the grep command and paste in this timestamp. And then just run that against our log file. And this is going to pull back any events with this same timestamp. And so it looks like a number of different requests were made within that exact second. And again, based on the user agent, is pretty par for the course for a brute force attack. And so now I want to see any unique file paths or URLs that were accessed. We know about the login.php file, but where was the attacker redirected to once they had the valid credentials? And there are a number of ways to do this, right? We can use cut and sort or even awk, but I'm just going to append another grep command to our previous command to filter out any entries containing login.php. And so to do that, I'm just going to add the pipe here, and then grep with the tac v to reverse or exclude, and then just put in login.php. And if I run this, well, this time you can see we have a single result from our same suspicious IP address with the same suspicious Hydra user agent, this time accessing the /admin.php page. So now it definitely looks like the attacker was successful, and we can use this information we identified to continue our investigation and expand the scope of our analysis. And there are so many different combinations of these utilities and tools that we can use to pull back very interesting information and find out exactly what we're looking for. You know, the possibilities are almost endless here. And so I won't be able to cover every single scenario, but the idea is to show you all of these different puzzle pieces or Lego blocks so you can put them together in a modular way to match any incident or log file that you come across. And with this lesson getting a bit long, let's conclude it here and take a look at grep and some regular expressions or pattern matching in more detail in the next lesson.